Hey guys, this is Shadecraft. Today we will be doing a kind of like a little ball through a maze tutorial. It's just going to be a little prototype, nothing too serious. So we're going to start out with a open scene here in Unity. I already have my scene saved as scene 1, all one word. Let's create a plane to start out with. Now we'll want to reset its position to 0, 0, 0. Oh, too fast. And just because I like having a lot of space to work in, I like taking my planes, especially my prototypes, to 10 by 10. That gives us 100 square, well, 100 units in each direction that we can work in. Alright, now that we've got that, let's go down to Assets. We'll create a folder for our materials, because even though this is just going to be a small prototype, we always want to maintain our organization. Alright, so now that we're in our materials folder, we'll create a material. We'll call it the ground material. And we'll change the color here to a green. 255. Let's go 33 by 255 by 33. I kind of like the off color there. Hit. And we'll go ahead and close this and apply it to our ground. Alright. Our directional light, we want to be at Y level 25. Because why not? That puts it up there. It's a directional light, of course. Rotation at 75, Y of 30, and a Z rotation of 0, and default scale. Excuse me. From there, let's add a few cubes for our walls. First, let's create an empty. Oh, nope. Create an empty called walls and reset its location to 0, 0, 0. And from here, we'll create a cube. And let's make the cube 5 tall. The position 2.5, because the insertion point is the center, and half of 5 is 2.5, so. And let's take it along the z-axis by, oh, no, scale it up. Let's make it 20. Now let's select it in the hierarchy here. Control D to duplicate. Now, I want there to be like a 3 gap. So we will move this one on the x-axis by 2. This one by -2. Now, because the insertion point is in the middle, that's half of 1. So it goes actually from -1.5 to +1.5, which is total measurement of 3. Now let's take this side, and instead of it being 20, let's just make it 16 and bring it down so it's even with the other one here. Yep, that looks good. Alright, now let's take this one, duplicate it again, and we'll get the rotation on a 90-degree axis. We will move it over here, and actually, nice little trick, if you hold control while you are moving an object around in the world, it'll snap by 1 full unit. Now, because of this being half units, we will have to say 5.5 on the X scale. actually. We want this to be lined up with this one. And then we will duplicate this one. Swing it by 90 degrees on the y-axis. Remember, in Unity, the y-axis is up and down. The z-axis is north-south, I guess. And the x-axis is east-west. Now, of course, the whole east-west is my assignments of the cardinal directions. And we want the position on the x-axis to be 7.5. That should line these two up quite nicely. And you know what? That's all we will do for this one for now. We'll come back to the end later. Inside our walls, we will create a sphere. Let's reset it to 0, 0, 0. Bring it up a couple. And let's scale it up to 1.5 by 1.5 by 1.5. That makes it a little bigger. You can make it bigger if you want, but the 1.5 should work nicely. Now we're going to create a capsule. We'll reset its position. Let's bring it up. I like to bring everything up in the world so that it drops in the... Just for prototyping, it reduces the possibility of things accidentally getting stuck in the ground. And on our capsule, which we are going to rename to player, and we'll rename our sphere. Rename our sphere to ball. Alright. And our player, we want to create a 3D object, a sphere on top of it. We want it to be a child of the player. And we are going to basically bring it up here so our little capsule dude has a head. We'll bring it forward just a little bit. Excuse me. Because it just looks better that way when you have the camera script. Now we will drag our main character and make it a child of the sphere, which we will rename to head. And take the main camera, and when we reset its position, that'll take it back to 0, 0, 0 as far as the head is concerned. This position, when it's a child object, is relative to its parent, not the world space. And so now we have that. So now let's go back to our root of our assets folder. Create another folder called script, and we will create a C# script and call it player controller. We'll go ahead and open up MonoDevelop, give it a second. Now what we're going to do is create it so that, or edit our script so that the WASD keys, now occasionally, sometimes this shows up, but this is, okay, object reference not set to an instance of an object, okay. When that happens, for whatever reason, usually I just can close out MonoDevelop and I open up again. But anyway, what I was saying was we will bring create a script so that the WASD keys or the arrow keys move our player around in the player space, or in the world space. And the end goal is we're going to push this ball around the corner, and we're going to set up like a little goal area over here, and when it goes in the goals, it'll just reset the scene. It's a prototype, it doesn't have to be fancy. Okay, so now that we have this is for our player controller. We want to, on line 5, say require component inside a square bracket, open parenthesis, type of, open parenthesis, character controller. Now what this does is makes it so that this script will only work if there's a character controller on the object that the script is attached to. Now, what we will do here is create a bunch of variables, both public and private, so that we can manipulate our character or maneuver our character throughout the environment. Now, the difference in, or the big difference in MonoDevelop and Unity as a whole, really, is a public variable can be seen inside the editor itself. So, for instance, we'll just say public game object head, semicolon. We'll go ahead and save it just for a quick example. Come down here, and let's go ahead and attach our player controller to our player. We'll select it and then drag our player controller over here. Now, since we wrote the script before we added, it imported the character controller as a default. If we had attached the script before including the required, then we would have had to add the character controller manually. But here we can see head is assigned to none. It's a private, or it's a public function. If we were to go into our script and say private, it would not appear in the editor at all. But because we are trying to assign a game object to it, I find it is easier to make it a public game object. Alright, so now that we've done that, now let's do public float move speed, and another public float for jump height, another public float for mouse sensitivity, another public float for our up-down range. We'll get into each of these as we go down, but normally I would make the up-down range or the jump height and all the other things private. But for the sake of game testing, we make them public so we can change them and see what feels the most natural. Now, for a private, we want a character controller, and we'll call it CC. Private float Y move, and our private float look up down. Alright. Now, in our start function, this function happens when the player controller, or in this case, our player is first initialized into the scene. So we want to call cc equals get component, and then we want to do lesser than sign character controller, greater than sign, just to close off the pair, and then open end parentheses. Now, the reason we're doing it this way is because character controllers and rigid bodies and things like that need to be initialized at runtime. So we call it a private, and then we just get the component here. Excuse me. Now we are done in our start function. We can get down to our movements. We'll just create a little comment here called movement. Now, you don't need to have the little space after the movement and the slashes, but I find it's easier to read sometimes when there's like an L when you're like when we're going down here for a look up down. And you know what, we'll just need one for rotate left and right. Alright, so our movement, we're going to create a float and we're going to call it ZMove. And that equals our input dot get axis, and it's a string called vertical. And we're going to multiply it by our move speed. Now, we know it's called the vertical axis for our W and S, or up arrow and down arrow, and I believe also, if you have a controller plugged in, up and down on the left thumbstick. You can get these names by going into Edit, Project Settings, Input. That brings up your input manager in your inspector. Drop the little axis here. Horizontal, vertical. You got fire 1, fire 2, fire 3. Those are the mouse buttons. Jump, that's the space bar. Mouse X, mouse Y, that's the mouse moving. The mouse scroll wheel, that's pretty self-evident. And then you have another horizontal and vertical down here. I believe, yes, this is where the joystick axes are handled. And up here you have left, right, and A and D. And W, S, and up and down. You can go in and change these if you want. If you want to have your negative button be, say, instead of left, you want it to be J. That would work. But we're just going to leave it as default and go back over to our code. So float xmove equals input dot get axis horizontal. And multiply that by move speed. Now, because this is move speed, it's okay that this is, being multiplied by the same thing. And then if our input dot get button. Now, here's the thing about the get buttons. You have get button down, and get button up. The get button will return true the entire time you're holding down the button. The get button down will only return true the first time you press it, and the get button up will only get it when you release it. Now, we'll just use get button jump, and that will do the space bar. And we want if you press the space bar, and if the character controller is grounded. The character controller handles everything so that if you are jumping, the character controller dot is grounded will return false, and that disallows double jumping. If we want to do double jumping, we can address that in a later tutorial. So in this case, we want to do YMove equals jump height. Else if Oh, else. Not CC dot is grounded. If our character controller is not grounded, we want it to do something else. We want Y move to equal Y move plus physics dot gravity dot Y. Now what this does, and we want this to be multiplied by time dot delta time. Now what this does, we'll handle this first, else Y move equals 0. Alright, what this does, Y move is being held out here, so it's class-wide. The jump, if you press the jump button and you're on the ground, then it'll move you up by whatever you assign the jump height to be. Other than that, if you're in the air, it'll add gravity to you at the rate of however long it is in between frames. And other than that, Y move is 0. There's no need to really be sucking you towards the ground if you're grounded. Alright, so with that saved, we'll go over here. Our player does have our player controller script. It has to update. Assignment. Getting an error message. Well, it's a good thing we saved. So I don't know why MonoDevelop decides it's always going to open up on my other monitor. Okay. Saying we have a little error. Oh, I accidentally used 2 equal signs. We're assigning, not comparing. Okay, Z move is assigned but never... Okay. So far so good. Now from there, we want to create a new vector 3. And we'll call it move. And that is equal to a new vector 3. X move, Y move, and Z move. And then we want CC dot move and pass in our new move script. And we will multiply our move by time dot delta time. This just makes it so that everyone's everyone's frame rate is going to be different. So this just makes it so that everyone moves at the same speed. Alright, that should be good. These should clear out. And alright, we'll drag our head over to our head slot here. Move speed 5. Jump height 5, and we don't need to worry about mass sensitivity or up-down range currently. We're just testing out our move, and pressing right, pressing left, pressing down, pressing up, pressing jump. Okay. We'll worry about the ball in a second. Since the ball has absolutely no script attached to it, it's just going to sit there. Not affected by gravity or anything. Alright, so now that we are done with that, let's rotate left and right. Now, mouse rotation is actually Yeah, rotation is actually pretty easy. All you have to do is transform, dot rotate, not rotation, rotate with a capital T, or capital R. New, vector 3, 0, comma, input dot get mouse, get axis, mouse, space, x, comma, 0. And now we can turn left and right. But we can't look up and down. Now, we could just do the same kind of thing for... If we did a transform rotate and made it so that we rotated around the x-axis, that would make it so that we would look up and down, but that would rotate the character itself, which is not exactly what we want. So we want it to rotate the head. However, we want to take it a step further and rotate, and we want to keep it so that you can't just flip your head around and around and around in vertical circles. So we need to clamp it so that you can only look up and down a certain range. And you know what? Let us take our mouse input.mousex and multiply that times mouse sensitivity. And actually, just to make it cleaner, we will create a new float, call it rotation, and that will just equal input get axis mouse x times mouse sensitivity, and then we will just say rotation, and of course end it with a semicolon. So from here, we want look up and down, which is our float that we created here. Look up down is minus equals input dot get axis string mouse y times mouse sensitivity. And then look up down equals mathf.clamp. Now this is actually pretty cool. Clamp, we take our variable that we want to clamp, so look up down in this case, the minimum version, so that would be negative up down range, and then our max, which is positive up down range. And then head.transform.rotate dot local rotation equals quaternion dot Euler new vector 3 wait a second. Yeah, new vector 3. Look up down. 0, 0. Alright. So now that that is done, make sure it compiles no problem. Hit play. Let's change our mouse sensitivity to 10. I like a good sensitive mouse. And I have found that the best rate for up-down range is actually 60. That gives us 60 degrees of movement up and 60 degrees of movement down. Now look at the bottom window here, and you can see we can only look up and down, and we're rotating quite well. Okay, so now that we have our character movement and rotation and looking down, let's focus on the ball for a second. Go back to our project window here, and materials. Let's give that ball a nice color. So material, ball material, and let's see, red is usually a good color for ball. So 255 by 0 by 0. And we'll select the ball, drag it over. In our scene editor here, we can see that it is now in fact red. And we want to add a component called a rigid body, apply gravity, and keep everything else except collision detection, which we will set to continuous dynamic. It's a little harder for the processor, but it's more solid because what we're trying to do is push the ball to the end of the hall here. Alright, so when we start the game, all we've done is seen that the ball is falling. Control P will stop play or stop playing the game. Alright, so now let's go back to our assets, our scripts folder again. Now, for this one, we'll just create a script and we'll call it ball. We're going to open up the script. If it loads. Let's try opening it up again. Here we go. And we're going to remove everything. Except for the... this is all we need. We're going to save, because we're just trying to assign the ball to a type. Now, there are other methods to doing this, but for prototypes, just for the sake of a quick prototype, we're just going to we're just going to put this on there. We can call it later. Alright, now we're going to create a C# script. This will go onto our player controller or onto our player character so that we can push the script around. So we will call this let's see, ball pushing. Alright. Now for this one, we can remove everything from here. And we'll call a public float push power. And we'll start out with an assigned value of 2. We can change it later in the editor if we find that it's too strong or not strong enough. And then we want private void on controller collider hit. Now keep in mind this is using Pascal casing, where the first letter of every word is capitalized, including the first word, as opposed to camel casing, which I use for my variables, which the first letter of the first word is not capitalized, but the first letter of every other word after that is. Alright, so what we're going to pass into this is a controller collider hit, which IntelliSense noticed, and we'll call it hit. And there we go, it's updated. Now we're going to say rigid body RB equals hit.collider.attach rigid body. If RB, our rigid body, equals null, in other words, if there isn't a rigid body, or if it's kinematic, we don't want it to do anything, so we'll just say return. Else if, oh, forgot my semicolon. Else if that's not how you do an if statement. And finally, an else. All right, else if hit dot move direction is less than negative 0.3. Now this just hit direction dot y. This way, if we're coming at it from a weird y angle, up down angle. All right, then we'll also want it to return. Now we could have put another or up here, but I like to group the rigid body checks with the hit check. I like to keep all the different types of checks separate. And now, if everything else if everything else is according to plan, then we're going to say vector3 move direction equals new vector3 hit dot move direction. My computer decided to lose focus there. Hit dot move direction dot x 0 and hit dot move direction dot y or z. And then we can say take our rigid body, add velocity, or just take velocity, and take it as push direction, or sorry, move direction times push power. All right. So let's go back into our scene here. And I don't know why Unity's being all weird. Take our player. And we will take our ball pushing script and add it onto player. Push powers 2. Now when we run the game, we can push the ball. Oh yes, you'll notice that we can't notice that while our movement is pretty good, we have a slight problem. All right, let me move the viewfinder over here. I'm moving sideways. Even though I'm pressing forward and backward, I'm moving sideways. That is because on our player controller script, we'll bring this back up, we'll maximize this. We need to take our move and make it relative. So from here we go move equals transform there we go, dot rotation times move. Now when we go into our script here, Let me move the controller over here. Now I'm moving forward and backward relative to my character whenever I move the mouse. Okay, so we're almost done. Now all we have to do is add a collider at the end, just as a win condition. So let's create 3D object, and we will call it, we'll make a cube. We want the Y to be, we'll say, let's make it a little shorter than the wall here. So instead of a scale of 5, we'll give this one a scale of 2, and its Y position will be 1. And let's just take and get these two good full numbers, and then adjust it into the middle where we see fit. And we will scale it up to an X of 3, or a Z of 3. Okay. So now we are going to create another C# script, and we are going to call it end goal. We'll go ahead and open it up in MonoDevelop. And for this one, we're going to need to use a couple more things. Using Unity Engine .scene management, and also using system. Now, this script is actually very much similar to our pushing script, except it just has to catch the collision. So, private void on collision, enter collision, and we'll call it hit as well. We don't have to worry about it having the same name because it's the same. It's a completely different script, and the two will never touch. So, at this point, we just say try. It's always good to do something like this in a try-catch block. Now, since it really does not matter if there's an exception, we don't have to assign a name for it or anything. It just has to catch an exception. So, try if hit dot collider, no, hit dot game object dot get component, and we want to call it ball. Scene manager dot load scene, and as a string for scene 1. Alright, now what this does is when it hits a collision, it looks to check if the hit has a component of the type ball. And if it does, then the scene manager just loads the scene. So, we'll go ahead and save. Go over to our Unity. Take the cube, which we will call goal, and add our end goal script to it. Alright, And to make sure that this will work, we want our build settings to include scene 1, which is named here. So when we hit play, we can go down here, push the ball, go around the corner, and when it hits that, it'll reset the game. Now, this is just a prototype. You can take and add more walls, make a huge maze, so you have to push the ball all the way through the maze, or even have to find the ball and push it back to the beginning. You could add scripts so that if you press the ball in a certain place, the wall lifts up and it even enters into a new area of the map itself. But for a prototype, all that matters is pushing and the event when the ball collides with the goal. And I hope that has been helpful.